This video shall give you an idea how to perform submaximal physical exercise in the magnet of an MRI system. This method is easy to perform, avoids large investments in commercial ergometers, and can be followed by patients with even severe cardiac disease. The centerpiece of this system is a non-magnetic scaffold which is made of aluminium. It is individually designed and has special locks to be mounted on the MR table.
Submaximal exercise is performed very simply and effective. A rope is led over a pulley fixed on the top of the scaffold. Cuffs at the ends of the rope are fixed to the patient's ankles. The exercise is performed by up and down movements of the patient's legs to a given number of repeats. The number of repeats is given by an electronic metronome transferred to the patient's headphones. This system is self-adapted and not bound to a fixed watt number. It means that every patient has to lift his own leg weight.
Now you see how the patient is prepared. For exercise, the patient's ankles are fixed in the cuffs. The length of the rope has to be adapted to the patient's body length. He should be able to move his stretched legs in an easy fashion without discomfort. The lower leg is allowed to touch the MR table. Avoidance of motion artifacts is crucial during exercise. For this purpose, two belts are crossed over the patient's pelvis and pulled tight. A grip handle is fixed on both sides on the table so that the patient can better control his thorax movements by grasping these handles.
Recording of stable EKG signals in the magnet during exercise is of great importance for proper measurement of ventricular contraction and blood flow analysis. Sometimes a stable EKG signal is difficult to establish because there is significant distortion of the EKG signal by the static and dynamic magnetic fields. Various individual positions of the electrodes have to be tried to optimize the R-wave signal. Outside of the magnet, the R-wave has to show a large amplitude, easy to differentiate from signal noise. A cuff for blood pressure recording is fixed to one arm. Now the cardiac coil is placed over the thorax and the patient transferred to the center of the magnet bore. Usually heart rate and blood pressure is recorded twice within 3 minutes under resting condition.
Now exercise is about to start. The metronome is set to a frequency of 144 per minute, which relates approximately to a regular Nordic walking speed. Now the patient starts to move his legs in the frequency given to his headphones. The ECG is clearly changed and distorted, but the R wave is properly identified. ECG triggering during MR sequences can be considered as reliable. Usually 5 minutes continuous submaximal exercise is enough to establish hemodynamic steady-state conditions. Typically, heart rate increases by 24% compared to resting condition. Now imaging and flow measurements can start. This is a pair of SSFP images for measurement of ventricular volumes and function. Left-sided, you'll see the image under resting condition, and to the right a corresponding image during continuous submaximal exercise. The latter one is somewhat more blurred, but you might imagine that the endocardial border can easily be delineated.
Continuous submaximal exercise has the potential for numerous studies in various, mainly congenital heart diseases. It is not suited for studies in coronary artery disease. Here you see the application of continuous submaximal exercise in cardiac MRI in 2 studies we recently published. The first one shows that the volume of regurgitation in patients with aortic insufficiency declines under exercise. The second example demonstrates that the amount of aortopulmonary collateral flow in patients after total cardiopulmonary connection is unchanged under submaximal exercise.